Students, hello students, welcome to Doxyverse. Today's topic is just an introduction to the topic ANS. This is pharmacology from Doxyverse. Okay, first, before starting, I'll say you one thing, something about our channel. Our channel only posts the question-based videos, but in this video, I'm not going to discuss any question, but I'm going to discuss some basics. Because without knowing this basics, you can't understand any concepts in the upcoming essays. That is for your university exams. So we might have come across these words many times, but we might not know the exact function and exact concept about the topic. Okay, this is an introduction to ANS. Okay, now let's get into the topic. What is ANS? ANS is an autonomic nervous system. It controls the involuntary movement of our body. We can voluntarily move our hands, muscles, we can move our eyes, but can we constrict or dilate our blood vessels? Can we increase our heart rate? Can we dilate or constrict our pupil? No, we can't. These are taken care by the ANS, which is involuntary. Okay. Now, what are the types of ANS? ANS is classified into two types, that is parasympathetic and sympathetic. So now you might have a doubt. How did we classify the ANS into parasympathetic and sympathetic? I will explain that. Based on the anatomy, see, this is the brain, and this may be a brain stem, and this is your spinal cord. Okay. Now think. We have a cranial nerve centers in our brain stem for third one, seventh one, and ninth one, and 10th one. Okay, these part of the cranium, that is of the brain stem, and some part in our sacral region, of a sacral part of our spinal cord. This part of a central nervous system contributes to the parasympathetic nervous system. Now, then what will contribute for the sympathetic? Remaining what? Lumbar and thoracic and lumbar region. So this thoraco-lumbar region of the spinal cord of the ANS contributes to the sympathetic nervous system. Okay, now we classified this ANS, sympathetic and parasympathetic system based on anatomy. How do they differ in the function? Let's discuss that. Now, what are the main difference? Okay, before that, we'll see the difference between the sympathetic and parasympathetic. Before that, we should learn how does the neurotransmitter works, how the neural junction works, what are the receptors involved, what are the functions of receptors, how the signal is transmitted from one neuron to another neuron. It's quite basic, but I need to teach you again to make you have a good idea about the concept. I make sure you don't lag in these concepts so that you will understanding of the upcoming concept very well. Okay, now see this. This is the presynaptic neuron, and this is the postsynaptic neuron. Okay. Why do the neurotransmitters stay? They will be packed in the vesicles. Neurotransmitter will be packed in the vesicles like this. Okay. Now, when do they get released? When the action potential travels in the nerve. Now, what do the action potential actually do? They opens the calcium channel present in the neurons. What calcium channels? What gated? Voltage gated or ligand gated? Calcium channels, they open when the action potential hits them. So, by the action of action potential, these calcium channels open, so they are voltage gated. It's very easy. Now, see, because of opening of these calcium channels, all the peripheral calcium enters into the neuron. These calcium makes a contraction of that these vesicles to the periphery of the neuron, and when it gets contact with the membrane of the neuron, it got exocytosis, and the neurotransmitters are released in the neuron junction or neuromuscular junction, and that is known as synapse. Okay, now see, there are receptors present in the postsynaptic part. In the postsynaptic part, when these neurotransmitters get attached, they start to open the sodium channel. It may differ based on the function of the neurotransmitter, but as of now, consider it is a sodium channel, and sodium channel opens, and opening of sodium channels, what causes? Sodium channel causes depolarization of postsynaptic part. It causes depolarization of postsynaptic part. Okay, understood? So be clear with this concept. Be clear with anatomy of sympathetic and parasympathetic concept. And next we'll move to the physiological function of the sympathetic and parasympathetic system. Now, see, what are the difference? First difference is location. Parasympathetic and sympathetic. So, what about the location? Where do I locate? They are located in the craniosacral region of the CNS. They are located at the thoracolumbar region. A main difference is their location. Then, what about the ganglion? What is the ganglion? Let's discuss that. What about the ganglion of the sympathetic and parasympathetic system? Let's discuss what is ganglion. Okay, I'll erase this and I'll teach you completely. Please wait. Okay. Now see, this is the brain again. And let this be the spinal cord. When a signal is transmitted from a system, from our central nervous system to a peripheral part, that is our eye or a peripheral organ or to our visceral organ, it crosses a junction like thing known as ganglion. This is known as ganglion. It's like more like a transformer. See, this is the central station where the power comes, and this might be a transformer, and the organ we target may be the house. So the current is not directly passed to our house, it passes through the transformer so that it get altered according to the organ, and then it is transmitted to the targeted organ. Now see, now this ganglion for the sympathetic nervous system is away from the site of action. It is away from the site of action. So see, this distance is more compared to this distance for sympathetic. But from the cranial part is what? It is parasympathetic. So for parasympathetic, this distance is more compared to this distance. So it is near to the site of action. Now see, it is near to the site of action. And sympathetic nervous system is completely opposite. Now see, this distance, let it be the thoracolumbar region, that is a parasympathetic region, to one visceral organ, let it be a heart or something else. This region is less and this region is more. So it is away from the site of action. Did you understand the two main differences? Then here where the concept starts. See, now we are going to learn about the receptors. Up to this, it was just an information for you to make you clear about the concept, make you understand all differences between these parasympathetic and sympathetic. But as of now, from now, you should remember these because it is going to help you to understand the action of drugs in the upcoming topics. If you understood the action of if you understood the function of the receptor and the action of the sympathetic or parasympathetic nerve on the particular system, you can predict the function of drug. Okay, now see, we have learned about the ganglion. Now we should see the receptors involved. Which receptors stands for? There are types of receptors. What are the types of receptors we know? Alpha, beta receptors. And if you don't know, learn now. N-type receptors known as nicotinic receptors. And M-type you might have learned in the physiology in the first year. That say in the secretion of HCl, M receptors, M3 receptors, it's known as, its full form as muscarinic receptors. Okay, what are the types? Alpha, beta, nicotinic, and muscarinic. In alpha, NN receptors means NN receptor. It is at the junction of neurons. NM receptor is nerve and muscle junction. Okay, M are present in the visceral organs, present between the neurons and the present between the neuron and the muscle. That is nicotinic receptors. M receptors are present in the visceral organs. Alpha, beta receptors we may see in the blood vessels, in the heart. Okay, now let's discuss what receptors the sympathetic and parasympathetic system acts. Okay, first ganglionic receptors. What is ganglion? What is ganglion? Tell me. Here, this is ganglion. Here there will be a receptor present to get the signal from the neurotransmitter. Parasympathetic system, the ganglionic receptor is N type. As I said, N is at the junction of two neurons. N is nicotinic. So N type is also present in sympathetic. So for both sympathetic and parasympathetic system, N type is a common receptor. So for the ganglionic receptor, for both sympathetic and parasympathetic, what is the receptor? N type, nicotinic receptors. Next, postganglionic. Now it is up to the ganglion. What about the postganglionic? When it reaches the organ, when it touches the organ, suppose alpha beta receptors is for heart, and nicotinic receptors and the muscarinic receptor is for visceral organs. Now see, when it touches the target organ or target site, what are the receptors? Through which receptors they act? Parasympathetic system act through the muscarinic, sorry, change the color to make you understand, muscarinic or nicotinic. And the sympathetic nervous system is, it might be alpha or beta. Understood? So what about the ganglionic? At the site of ganglion, for both parasympathetic and sympathetic, it's nicotinic receptors. What about the postganglionic site? It is muscarinic or nicotinic. For sympathetic, it might be alpha or beta. Okay, now it's clear, I think so. Now see, let's discuss about the neurotransmitters. What are the neurotransmitters to which the signal is passed? Now see, for what? For sympathetic, it is only acetylcholine. No other neurotransmitter is used. If you ask for the neurotransmitter of the parasympathetic nervous system, it's only acetylcholine. No other neurotransmitter is used here. When we come to the case of sympathetic nervous system, there are different neurotransmitters for different ganglions. For example, for preganglionic neurotransmitters are acetylcholine, and postganglionic neurotransmitters are norepinephrine, dopamine, dopamine, and also acetylcholine. So let's see where all these receptors come. Dopamine acts on the renal blood vessels, causes vasodilation. What happens when a renal blood vessel dilates? It leads to the diuresis. In case of acetylcholine, it acts on the adrenal gland, sweat gland. Okay, these are the main difference of sympathetic and parasympathetic nervous system. And if you understood these introduction about the ANS, you can easily understand the upcoming topics. Okay, so don't worry about the ANS. It's a lot of drugs to mug up. I'll teach you the concept thoroughly, so it will be easy for you to mug up. So, and I want to say you students, don't just study for marks. It's not going to help you. It might show you as an smart. It may show you smart in your class among your friends, but actually you're not smart if you're only looking for your mark. Please understand the concept. Read K.T. Tripathi. It's a very good book. Don't go for any low standard books. Okay, K.T. Tripathi is a very good book, and please try to understand the concept. Okay, and I know it's very difficult for you to read every day. I will post my videos. In my video, I'll explain every concept in a particular essay, in a particular question. Watch the video, go back, take your book, read the lines, or if it is more for you to read the book, I will give you notes for every essay that is from those lines are from K.T. Tripathi, so that your way of studying will be so standard. The standard of studying won't get reduced. Be in a standard. We are studying MBBS, so please maintain the standard and learn all important concepts. And first year and second year is like an ABCD. Without that, you can't learn second, third year, and fourth year. You'll struggle in third and fourth year. Okay, students. I hope you would understand what are the functions of sympathetic and parasympathetic nervous system. And main I didn't teach the functions yet, right? Okay. Now I'll teach the functions. It's very easy, students. Understand the functions, understand the mechanism of the receptors, understand the neurotransmitter. It's very easy for you to learn the drug. Just you need to mug up the name. No need to mug up any adverse effects. No need to mug up any the side effects of the drug. Just you need to mug up the drug, name of the drug. If you understood all these concepts here itself. Okay, come on. Let's finish the concept now itself. Learn the function of one system, that is parasympathetic. The function of another one, that is sympathetic, will be opposite to the parasympathetic in most of the case. Not in all case, but in most of the case. Okay, first we will learn about these functions of parasympathetic, that is effect of parasympathetic nervous system on the each system. First, about CVS. What it does to the CVS? It decreases the heart rate, slows down the heart rate, and promotes the relaxation. Next, what about the digestive system? It increases the salivary production. It increases the gastric production, intestinal motility, and motility is contributed by the peristalsis. So it enhances the contraction of smooth muscles in our intestine. Next, enhances the absorption. Then in eye, it contracts the pupil. Then in lungs, it causes bronchoconstriction. Then what about in bladder? Promotes the contraction. So what happens when the bladder contracts? Enhances the urine production. So this is how it helps. These are the effects of the parasympathetic nervous system on each system. Okay, learn this. And exact opposite of these effects are produced by the sympathetic nervous system. So here, heart relaxation increases the heart rate. Salivary production is decreased. Gastric secretion increased. Gastric secretion is decreased. Intestinal motility is decreased. Pupil is dilated. Bronchodilation, dilation of bladder. These are the functions of sympathetic nervous system. These are the effects of the sympathetic nervous system. So if you are thorough with this, all this, it will be easy for you to learn the effects of the drugs on each system. Some of the drug has the opposite effect of the parasympathetic nervous system. So if I say atropine has an opposite effect on the parasympathetic nervous system. What are the opposite effects? It decreases heart rate, it increases heart rate. Digestive system is enhanced, digestive system is diminished. Pupil is contract, pupil is dilated. Bronchoconstriction, bronchodilation. Bladder is contracted, bladder is dilated. These are the functions of atropine because it produces the opposite effect to the parasympathetic nervous system. It blocks all the receptors of the parasympathetic nervous system. So before getting into the essay, before learning the essay, please learn all these basics. These basics are also given in the KD Tripathi. Read that or else listen this lecture. It's more than enough. No need to read anything extra. And from next lecture, I'll start an essay and I'll explain each and every concept in that. Okay. So your work is, what is your work? To understand the question, to learn the question. Let's watch the lecture. Listen very carefully and go back, take your book, read that. If you don't have the patience to read the book, I have given the notes with every point in the KD Tripathi. Read that and your work is done. We are very strong in your concept. You can also write the every points in your exam. So try to read standard books. Don't go for low standards. Don't settle for less. Okay. With this, I'm ending the video.